In this video, I'll be giving you an introduction to Kubernetes. Specifically, I'll discuss what Kubernetes is, some Kubernetes terminology, and the basic Kubernetes architecture. After that, I'll transition to the computer and show you how to create and connect to a Kubernetes cluster. Then, once we've created a cluster, I'll walk you through a simple demo of deploying a basic Flask website using Kubernetes. Now, if you want to follow along with this video and create your own cluster, you can do this locally on your own computer, or you can use a cloud provider like Linode, which happens to be the sponsor of this video. So what is Kubernetes? Kubernetes, also known as K8, is an open source container orchestration system used for automating software deployment, scaling, and management. It was originally designed at Google, but now is maintained by the Cloud Native Computing Foundation. Kubernetes typically works with Docker containers and microservices and automatically creates, destroys, and manages containers based on scaling and performance needs. Kubernetes allows you to easily scale your applications by running multiple containers and having requests load balance between them automatically. Kubernetes also prevents significant downtime by automatically recreating containers when they die and/or crash, and ensuring a predetermined number of containers is always running. So to better understand Kubernetes, let me quickly describe some key terminology, starting with a pod. So in Kubernetes, a pod is an abstraction of a container, usually a Docker container, but it can be other types of containers as well. Now, pods are where your applications and microservices will be running, and they have the potential to crash or to die. Now, every single pod is assigned a dynamic internal IP address that allows it to communicate with other pods that are running. Every time a pod dies, a new one is created and it will be assigned a new IP address. Next, we'll talk about a node. A node is simply some server that is running pods. It's also commonly referred to as a worker, and it usually runs multiple pods at the same time. So pods are an abstraction of containers, and then your nodes are running multiple pods or multiple containers at the same time. Continuing, we have a cluster. A cluster is simply the set of nodes that are running the pod/containerized applications. One cluster may contain many different nodes. Next, we have what is known as a service. Now, a service is assigned a static/permanent IP address and allows you to communicate with different pods. All of the requests being sent to a pod will first go through the service, and this service will act like a load balancer and send requests to the appropriate pod, typically the one that is less busy. You can have both internal and external services. Now, an internal service is one that's only accessible from the nodes within the cluster, and an external service is accessible from outside of the cluster. For example, you may have an internal service for your database pods and an external service for pods that are running your public-facing website endpoints. Lastly, here we have a deployment. Now, a deployment is the specification for what pods Kubernetes should run and how many of them should be running. A deployment is an abstraction over pods, meaning you don't have to create pods yourself, you simply define the images you want each set of pods to run, and then the number of replica of those pods you want to always be running. For example, you may want to run 3 replicas of a pod that contains an API. If that's the case, you specify this in the deployment, and Kubernetes will ensure 3 replicas are always running. If one replica dies, it will automatically create another one for you. So now that we have some of the key terminology down, let's talk about the basic Kubernetes architecture. Now, I'm going to give you a very high-level overview of how Kubernetes works. There's a lot of details I'm skimming over, but this will give you the basics. Just keep in mind there's a lot of other awesome features in Kubernetes that I'm not discussing in this video. This is meant to be a very basic introduction. If you want to learn more, then leave a comment down below, and maybe I'll make a follow-up video in the future. So let's start here with how nodes function. Well, each node must run 3 applications: a container runtime, so something like Docker, Kubelet, and kubeproxy. Now, Kubelet is the application that interacts with pods and the node, and kubeproxy is what proxies and load balances requests to the correct pod based on the defined service. So kubeproxy runs on every single node, and that implements part of the Kubernetes service component. So it's a lot more complicated than this, but kubeproxy essentially ensures that requests go to the right place. So all 3 of those programs, Kubelet, kubeproxy, and then some type of container runtime, are required on every single individual node. Okay, so now we need to introduce a new concept known as master nodes. So in a Kubernetes cluster, you have master and slave nodes. Now, the master nodes are what you as the system administrator or DevOps engineer would interact with, and those manage all of the slave nodes and handle things like authentication. So the slave nodes are those that are running the actual applications and pods. Now, in a large system, you have multiple master nodes, and these master nodes typically require less system resources than the slave nodes because they're not actually running any system applications, they're just handling all of the slave nodes. So to clarify here, let's go through a simple example. Let's say you have a cluster containing one master node and 3 slave nodes. To create a deployment and start running pods, you send a request to the master node containing the deployment that you want to run. The master node then talks to all of the slave nodes and handles the creation of all of the necessary pods, services, etc. So you don't have to manually touch any of the slave nodes or create any pods yourself. The master node does all of this for you. All you have to do is send it a deployment. So essentially, you're going to be interacting with the master node using an API, and then the master node is going to do all of the heavy lifting for you, handle all of your slave nodes and other servers, handle creating pods, and really everything that's going on behind the scenes. So that is the basics on Kubernetes. As I said, there's a lot of details I've left out here, but this is really all you need to understand to start working with Kubernetes and deploying some simple systems. With that said, let's hop over to the computer and create our first Kubernetes cluster. Alright, so I'm on the computer, and the first thing we need to do here is create a Kubernetes cluster. Now there's 2 methods to do this. The first way is to use a cloud provider like Linode, which is what I'm going to do in this video. The second way is to set this up locally on your computer using something called Minikube. Now, I recommend the cloud provider approach because Linode has sponsored this video and they're going to be giving all of you $100 in free credit for 60 days. So it's completely free to follow along with this. I actually think the setup is way easier on Linode than it is doing it locally. And this will allow you to get a feel for what it's like to actually work with a remote server and have multiple nodes running, as opposed to doing it locally on your own machine where you're kind of simulating or faking it in a sense, and you have only a single node, which is your own computer, that's going to be running the master node as well as all of the pods. So again, recommend the cloud approach, but if you want to do it on your own computer, that's totally fine. I'll explain how to do that in a minute. For now, though, you can go to the link in the description. It is linode.com/techwithtim. Sign up for a new account, and again, you get $100 in free credit. For this tutorial, we're going to use like 15 cents worth of stuff just because we're only going to be running this for, an hour or however long. Once you're done with the services, of course, you can delete them and you won't be charged for them. Okay, so sign up for a new account. I already have one, so I'm going to sign in. Then I will walk you through how to create the cluster on Linode. All right, so I'm on my Linode dashboard, and I just wanted to quickly mention that I've worked with Linode for over 2 years now. I actually have a bunch of servers and development projects that are ran with Linode. In fact, we have a Kubernetes cluster that runs a website and some APIs and stuff that I have going on for my Discord server. Anyways, just wanted to mention that this is a great company, worked with them for a long time, and there's a reason why they're sponsoring this video and some others on the channel. Regardless, what we want to do is create a Kubernetes cluster here. So we're going to go to Kubernetes, and we're going to click Create Cluster. Now, Linode has their own Kubernetes engine, which makes it really easy to set up a cluster and have everything initialized for you. So you don't have to go in and do any manual setup yourself. You just kind of look at this user interface here, select what you want in the cluster, and it will set it up for you. So for the cluster label, I'm just going to go with tutorial for now. For the region, I'm going to go with Toronto. They have a bunch of other regions, so you can select whatever one is closest to you. And then for the Kubernetes version, we can go with 1.22. It doesn't really matter what version you select. Okay, now we need to add a node pool. So the node pools are going to be all of the individual servers that are running as a part of our Kubernetes cluster. So you can select which ones you would like and the quantity that you want to have. Now, Linode recommends that you have at minimum 3, so up to you, but you can do 2, you could do 1, but you are going to run into some availability issues and just performance issues if you have less servers, right? The more servers you have, the more available your application is going to be. And if I go here, notice that we have stuff like shared CPU, dedicated CPU, high memory, a bunch of different options. I'm sure you guys can read through the specs on your own. For now, though, let's just go with 3 Linode 2 GB servers, which are $10 a month. So I'm going to click add here. The quantity was 3, so I've added those in. Then if I wanted more, well, I could add those. Okay, so now that I've done that, I'm just going to click on create cluster. And this is going to take a second. And once it's created, I will be right back. All right, so all of my nodes here have been created. And if I go to the Kubernetes tab, you can see that I can click on tutorial and I can see my node pool, which are just connected nodes, right, in the Kubernetes cluster. Now it's automatically given them a name for me. I have 3 of them and they are all running. Now that's as easy as it is to create a cluster. I'm going to show you how to connect to this in a second, but for now I will quickly go through how you can do this locally in case you didn't want to use the cloud provider. So here is the Minikube documentation for getting started. This is not overly complicated, but it is a few more steps than the cloud provider. So I'll leave this link in the description. And what you can do is install this program called Minikube, and then you can run the command minikube start, and that will actually allow you to treat your own local device as a Kubernetes cluster. Now, again, go through the installation. I'm not going to walk through it because it differs based on your operating system. You're going to start your cluster, and then if you want, you can look at the interact with your cluster and deploy applications, although I'm going to explain how to do that in the next steps in this video. So I'll leave that link in the description. Again, walk through this if you want to do this locally. So now that we've done that, let me close this here. What we need to do is install a program here called Kubectl. So as I said, what we're doing is we have our Kubernetes cluster. In our case, we're having this hosted in the cloud. If you're using Minikube, it's going to be on your local machine, and we need a way to interact with the cluster, specifically with the master node of the cluster. So there's this command line tool called Kubectl, and you download this or install it on whatever computer you want, not one that's running the cluster, but one that's going to be interacting with the cluster. So in the case of Minikube, yes, it will be on the same computer, but in our case, we have a Linode cluster out in the cloud. We install this on our local machine, and then it allows us, to send requests to the cluster after we connect to it. So just keep that in mind. This is kind of our way to interface with the cluster. This does not need to be on the same machine that is running the cluster or on the master node or anything along those lines. We're just communicating with the master node using this. So I'll leave this link in the description as well. You want to install this for Linux, Mac, or for Windows, right? So whatever operating system you're on, click on the appropriate link. On this case, I'm on Windows, and what I would do is use this curl command. So I'd say curl-lo. I would paste this, and in fact, I'll run through the installation. If you are on Mac or if you are on Linux, it'll be slightly different, so just click on the appropriate link. Anyways, what I'm going to do is use this command. So I'm going to open up my command prompt here. I'm on Windows. I'm going to cd onto my desktop, and I want to make a directory, mkdir. Okay, so let's say mkdir, and let's go with K8. And I'm going to cd into K8, and I'm just going to run this curl command in the directory so that my program here, Kubectl, gets saved inside of this directory. Okay, so I'm going to run this curl command. This is going to take a second to download. And now, if I have a look in this directory, we can see that I have the kubectl.exe. All right, so now that that is installed, or at least downloaded in our directory here, I need to add this to the system path. Now, this is going to be different if you are on Mac or Linux, so you'll have to look up how to add a program to the system path. It's not overly complicated from what I can remember, but obviously I'm not on a Mac right now, and so I can't show you how to do that. So you need to add this to the path. The way you do this on Windows is you type in env and you access the edit environment variables for your account. You then go to the path variable and you either double click on it or click edit. Now inside of here, we want to add the location of where we downloaded the kubectl.exe. So I'm going to go down here. Notice I already had this because I installed it somewhere else, but I'm now going to change the location so it's actually where I installed this, this exe file, where I downloaded it. So in this case, it's on my desktop. It's in the K8 folder, and then the name of it is kubectl.exe. Okay, so there we go. I'm going to click OK. OK, and now it should be saved. And now that I've added this to the path, again, on Mac and Linux, it's going to be different, but you need to add it to the system path. What you can do is open up a new command prompt here or terminal window if you're on Mac or Linux, and type in kubectl. Now, when you do that, you should get some output here. If it says it is not a recognized command, then that means you did not successfully add it to the path. Okay, so now that we have kubectl installed, what we need to do is link this with our cluster. Now, if you followed along with the Linode instructions, you need to follow the following steps I'm about to go through. If you installed Minikube, it should be automatically linked for you, but if it's not, you'll have to reference the Minikube documentation. Anyways, we're going to go back to Linode here, and I'm going to download this kubeconfig file. So the way I find this is I go to the Kubernetes tab, I click on my Kubernetes cluster, and then you should see something that says kubeconfig, and then there's a YAML file here. So what we're going to do is click on that and download it. So I'm going to download it into this K8 folder, and it's named tutorial and then kubeconfig. Okay, so I'm going to hit save. Now that I've done this, what I need to do is create an environment variable that references this file. And the environment variable needs to be named something specific. I'll show you that in a second. And once we create that environment variable, then kubectl will know to look for that and to use this configuration file to access our cluster. So this config file here, I can click on view and I can have a look what's inside of it. You can see we have a certificate, we have our token. Essentially, it has the authentication to our master node and to our cluster. So we're able to send requests to the cluster that are authenticated, and we don't need to kind of do anything manually. We just link this file essentially. And again, if you did this locally with Minikube, it should already be set up and connected for you. So what I'm going to do here is go back to my environment variables. Okay, and notice here that we have this environment variable called kubeconfig. Now, again, on Mac and Linux, to create this is going to be different. You're probably going to have to use the export command from your terminal. But on Windows, what I can do is simply create this variable if I don't already have it, or edit it. So let me just delete it and let's recreate it to go through the steps. So this is called kubeconfig in all capitals. And then the value of this needs to be the path to where you downloaded this file. So the path of this file is c:/users/tim/desktop, and then this is /k8, and then the name of the file, I believe, is tutorial. And then the path for this, actually what I can do, I should have done this before, is just click on browse file or browse directory. And now I can just go and actually find where this file is. So it's in Tim, it should be in desktop, and then K8. And okay, so K8, and then the name of this is going to be tutorial kubeconfig.yaml. So you just need to find where you downloaded this and put the path to the downloaded file. Again, that's in the kubeconfig environment variable. All right, I'm going to click OK. Now we can see that we've created this environment variable kubeconfig. I'm going to click OK again. Now I'm going to restart my terminal window. I'm going to type on cmd, and now kubectl should be connected to my Kubernetes cluster, and I will show you how we can test that. All right, so the command that we're going to run to test to see if we are connected successfully is simply kubectl, and then this is going to be get and pod. Now, this is going to give us a list of all of the pods that are running. Now, in this case, no pods are running in our cluster, but notice we didn't get an error from this command, meaning we are connected, and yeah, we get this result, no resource found in default namespace. Now, as I go through this, you will see a bunch of terminology that we have not yet covered. For now, you can simply ignore it. For example, namespace, you don't need to know what that is. Just understand what a pod is, a service is, and a node, and then a few other things as we go through. Anyways, that was getting the pod. The next thing that I will do here is look at the services. So let's say kubectl get, and then let's go with service. Now, when I do this, notice we have one service. Now, this is the cluster IP, and it is 10.12.0.1. This is a default service that's going to be on all of our Kubernetes clusters. Okay, so we've now looked at how to get the pods, how to get the services. We can also get a deployment. So we can say Kubernetes, or not Kubernetes, kubectl get, and then deployment like that. And of course, we don't have any deployments because we have not created any. So now let's create our first deployment. Now remember, the pod is the smallest unit that we have, and we don't interact with the pod, or we don't at least manually create the pods. What we do instead is we create a deployment, and the deployment specifies the pods that we should be running. Right now, I will create the most basic deployment that I possibly can. Then I will show you how we write deployment configuration files and how we actually, I guess, deploy or execute those configuration files and send them to the master node. For now, though, let's create a simple deployment just so we can look at a few things. I'm going to say kubectl. This is going to be create, and then I'm going to create a deployment, but I could create a few other things as well, like a service, for example. And I'm going to put the name of the deployment. Now, here we can do something like MongoDB, because what I need to do is pass an image, and the image is going to be what the pods should be running, or the containers in the pod should be running. So I'm going to say kubectl create deployment MongoDB, and then -- image is equal to, and then I can put any Docker image here from Docker Hub. So Docker Hub is a place where a bunch of Docker images are hosted. If you're unfamiliar with Docker, then check out my Docker tutorial. I will leave it on the screen as well as a link in the description, because I'm not going to be explaining all of the Docker concepts in this video. Regardless, we place the Docker image that we want this deployment to run for the pods. So now I'm going to hit enter, and we can see that we have created this deployment. So now if I run kubectl get deployment, you can see that we have the MongoDB deployment, and it says 0 out of 1. up to date 1, availability 0, age 5 seconds. Now this is because it's booting up the container right now. So if I do something like kubectl get pod, you can see that we have one pod. We have a MongoDB pod that was created for us. It has some ID here, and then it's not ready because we are creating the container. So if I give this a few seconds, then I run this command again, we now see that this is ready, the container is running, and there you go. We've just created a deployment. The deployment then ran the pods for us, and now if this pod were to die or to crash, it would automatically be recreated by Kubernetes for us. There you go. So that's as easy as it is to start working and actually deploying something out. Now, the image that I picked here is just a random image. I just picked the Mongo image just so we had something to kind of mess around with. Later, I'm going to show you how we deploy our own image so we can actually deploy a sample Flask application. For now, though, let's have a look at how we can do something like view what's actually going on inside of the pod. So this is my pod ID, or my pod name. So I'm going to copy that with Control C. And now I'm going to use a command that gets the logs of this pod. So I'm going to say kubectl logs, and then I'm going to paste the pod name. Now, when I do this, we're going to see everything that's happening inside of this pod. Now, it may be pretty meaningless to us, but sometimes this is useful for debugging and allows us to view, what the output is in the pod. Okay, so let's clear this. Let's run another command. Now, another command that I have found very useful here is called exec. Now, what this command allows you to do is actually get inside of the interactive shell for a pod. So I can say kubectl exec and then -it for interactive shell. Then I'm going to put my pod name, which is this, and then I am going to put -- bin / and then bash. Now, this is actually going to put me in a bash environment for this shell, although I need to do a space here after the --. So I just cleared the screen so it was fresh here, but now you can see I'm inside of the interactive shell. And inside of here, I can type a command like ls. I can cd into the home directory. I can ls inside of here. And I can essentially debug the container that's actually running, or the pod that's running, by getting into it in that way. Now, if I want to exit, I'll type exit, and that will bring me back to my main commands line. Okay, so those are a few basic commands to deal with pods and to deal with deployments. Now let's have a look at how we can delete pods and delete deployments. So I can do something here like kubectl get and then pod. All right, this gives me the pod name, so let's copy this. And now if I want to delete the pod, I can do something like kubectl delete pod and then paste the pod, and notice it's going to say that it was deleted. However, if I now go to get the pods, notice that one is running with an age of 4 seconds. The reason it's running is because as soon as this pod is deleted, our deployment now has said, okay, well, one was deleted. We need to run another pod because this pod died or this pod crashed. So just trying to show you here the power of Kubernetes. A pod crashed, it died, and a new one was automatically created. So how would we prevent this from happening? What happens if we actually want to remove, say, the entire deployment? Well, I can do that. I can remove the deployment. So I can do something like kubectl, and then I can say delete deployment. So let's do this. And then the name of the deployment, which I believe I called MongoDB. So now I've deleted the deployment. And if I go to get my pods, notice we have no pods because we would have removed all of the ones that were associated with that specific deployment. All right, I think that is really all I need to show you for the basic Kubernetes commands. There, of course, is a lot more stuff that you can do, but this shows you how to get the pod, get the service, get the deployment, create a very basic deployment, as well as how to delete a deployment and delete pods. Next, what I would like to do is actually go through an example where I demonstrate how we deploy our own application, because that's going to be a lot more useful than just going through some basic commands. All right, so now we're going to start going through this Flask deployment. Now, all of the code that you will see here will be available from the description. You can click on the link that says GitHub repository or something along those lines, and you'll see the Docker file, the config.yaml file, main.py, as well as requirements.txt, and I'll explain all of these files in a minute. However, I want to start with this file right here. So for this application, we need to have a deployment, and this deployment needs to specify what Docker image we want to run. That Docker image is going to be a custom image that's going to contain our application, and in this case, we're going to make 3 replicas of it. Now, what you're looking at is the configuration file for this deployment. So oftentimes when we are deploying applications, it's not enough to simply run a single pod and all of the options for our deployment we don't want to specify in the command line. So instead, we put them in a configuration file, and then we can use the configuration file as our deployment, which I'll show you how to do later on. For now, that we have a very basic config.yaml file, I will not walk through every single line in this, but I'll go through some of the important ones now. So this is YAML, Y-A-M-L, okay, file extension mostly for configuration. And inside of here, I have an API version. I have the kind of this file, which is a deployment, because we can create other things as well. We can create a service, right? We can create a namespace. We can create all these other things that I haven't necessarily talked about. The only ones we're really familiar with are deployments and services. So I do my kind. I have some metadata, the name of this, the labels associated with this, and then I have my specification for what I actually want for my different pods. So I say replicas is equal to 3. Now that means we're going to run 3 replicas of all of the pods that I specify here. Then I have selector, I have my template, and I have my spec here for the different containers that I want to run. You can read about all of this, all of these different, symbols or fields from the Kubernetes documentation. For now, you can just kind of copy this file, again, from the link in the description and work with it and just change some of the important aspects. So here I have my containers. Now, the container name is going to be Flask Web, and then the image is going to be a custom Docker image. I'm going to show you how we create this in a minute. And then for the ports, I'm saying I want to expose port 5000 because that's the port that my Flask application is going to run on. So this will now create, when I send this deployment over to my master node, 3 pods that are running this image that are all exposing port 5000. Now, the issue is we need a service that's going to allow us to actually interact with our pods. And so what I'm going to do is paste down here a service. Now, I put 3 dashes. The 3 dashes means we're going to have a new file here, a new config. And so you can place kind of as much as you want in a single file if you separate it with 3 dashes. And now here I'm saying my API version is v1, my kind is service, my metadata name is Flask service. And then for the specification, what I need to do is essentially link different ports. And I need to specify that this is going to be an external service. The reason it needs to be external is because I want to be able to access the website from outside of the nodes, right? Outside of the Kubernetes cluster. If this was something like a database or an internal API, then I would not make this an external service. I would make it internal because then only the applications in the cluster would be able to access it. I understand this is a lot, but just bear with me for now. Okay, so we have our kind service, metadata, then we have our spec, and inside of here we specify the ports that we want to have exposed and kind of linking with. So in this case, I'm saying, okay, port 5000. Now what that means is that I want the port for this service to be 5000. So I'm going to go to the static IP address of this service, which I will show you how to get, and then port 5000, and that is going to proxy the request to the target port, and the target port is the port on my pod that I want to actually access. So in this case, I want to access port 5000 because that's the port on my pod, and I access it through port 5000 on my, on my service, okay? Now, I can make this port something different. I can change the target port. They do not have to be the same. In this case, I'm just making them the same, and then the protocol, of course, is going to be TCP. Okay, for the selector, I'm saying this service is going to be for the Flask Web container or the Flask Web pod. So that's why I have Flask Web here, right? And then the type is going to be load balancer. Now, this is kind of a misleading name, but what this essentially means is that this is an external service. All right. So that is really all we need for this file here. Again, I understand not all of this is completely clear. I don't want to explain every single line. You can find that from the Kubernetes documentation. For now, though, this is the file we'll use to actually deploy our Flask application. Okay, so this is our config file. However, we now need to actually get the code for our app and see how we're going to deploy that. So I have this main.py file, and this is what's going to be running my Flask application. Again, available from the link in the description, but I just import Flask, create my app. I create a very basic route that's going to render some HTML. Hello, this is the main page. And then an H1 tag that says hello. And then I have if _name is equal to main. I'm going to run the app. And when I put the host of 0.000, that means that this is going to run on the IP address of the machine. So rather than running locally on localhost, it's going to run on the public IP address. And then I'm running this on port 5000. Okay. So that is the main code of my app. I then have requirements.txt, which is for Python, just saying what requirements we need to run this Python code. In this case, it's just Flask. And then I have a Docker file. Now, again, I'm not going to explain all the Docker stuff because I have an entire video on that. But the Docker file is essentially the image, is going to be used, to create an image for my application. So I have from Python 3.6 slim. This is the base image that I'm going to use. I'm then going to run this command. I'm going to run this command, which is going to install Python, nginx, and build essential, which I need to run my website. And then I'm saying I'm going to copy the requirements.txt file to the container. And then I'm going to run the command pip install -r requirements.txt. So inside of my container, it's going to install Flask. Then I'm going to copy the main.py file. I'm going to expose port 5000 on this container. And then I'm going to run the command python3 main.py, which will start running my Flask server. Now, this will happen 3 times, right, inside of the 3 replicas of my pods. So each one of them will be running an instance of the main.py file, and then the requests that are sent to this will be load balanced between the different nodes or between the different pods, sorry. Okay, so that is the code that I have. So now that we've kind of walked through all of this, we need to first create our Docker file, our Docker image. Let's go here. We need to create this image, and we need to upload it to Docker Hub so we're actually able to access it from inside of this config.yaml file. So what I need to do here is go to my command line. So now what we need to do here is build a Docker image and upload that Docker image to Docker Hub. So actually, I'm not going to go to my command line quite yet. What I'm going to do instead is tell you to download Docker Desktop if you don't already have it, or just download Docker. So you need to have Docker on your system. Again, if you're unfamiliar with Docker, I will leave a link to a video on it in the description. But download Docker. Once you've done that, you need to create an account on Docker Hub. Docker Hub is where you're going to host your image, so it's accessible from your Kubernetes cluster, and then you are good. Now, keep in mind your username because you're going to need that username. So again, download Docker, install that on your system, and then go to Docker Hub, create an account. And once you know the username of that account, you can follow along with the next steps. So from your computer, open up Docker Desktop if you have it, and you're going to need to authenticate with Docker Hub by signing into your Docker Hub account so that you can then push an image to Docker Hub. So up here, you should see something that says account or sign in or whatever. So click on it, and then you're going to be prompted to sign into your account, sign into the Docker Hub account you just created, and then you should be automatically linked with the Docker Hub account so you can push images to Docker Hub. In this case, I'm already signed in, so of course I don't need to do anything. Okay, now that I'm signed in though, I'm going to go to my command line, and now we can actually start writing some code. So the first thing I need to do is build a Docker image and push it to Docker Hub. So I need to locate my Docker file to build the image from. So I'm going to go cd, it's actually in my downloads, and then a folder called called test. Okay, so inside of here, you see I have my config.yaml, Docker file, main.py requirements.txt. Now I'm going to build my Docker image. So I'm going to say Docker build. I'm going to put a dot. This is the current directory where my Docker file is. So that's why I'm putting dot. Then I'm going to do -t for the name. And it is very important here for the name of your Docker image that you prefix it with the username of your Docker Hub account. So I'm going to say tech with Tim0, which is the name of my Docker Hub account, / and then you can put whatever name you want here for the image. So since I already have one called Flask Web, I'm going to go Flask Web Tutorial. Okay, so you put your username, you put the name of the image, or actually what may be called the repository that this image is going to be a part of, and then colon, and then the name of the actual image, which in this case I'm going to put as latest. Now you can name this whatever you want. I misexplained this a little bit. Again, we have username / and then this is your repository, because theoretically you can have multiple images in the repository, and then you put the name of the image after the colon here, which in this case is latest. You don't have to know what all of these mean so long as you have this kind of string right here and you can use it. Okay, so now that we've done that, I'm going to hit enter, and it should start building my Docker image for me from the Docker file. So once this is done, I will be right back. Okay, so we have now created this Docker image. So if I want to view the images, I can say Docker, and I think just images, and it will show me all of the ones I have. Notice I was messing around with this previously, and hence I have a bunch of different images. But I also have tech with Tim0 / Flask, and then web tutorial. So I'm going to copy this, okay? And now I'm going to push this to Docker Hub, and this will only work if you signed into Docker Hub. So let's clear here, and let's push. So I'm going to say Docker push. And then I'm going to push the name of the image that I just made. So I need to add the latest here as well. Okay, so Docker push username / repository name colon name of image, which is latest. Let's hit enter, and then it should push it to Docker Hub. All right, so it looks as though this has finished and I've pushed it to Docker Hub. So let's have a look and verify here. So if I go to Docker Hub and I refresh, we should see now that we have a new repository, and we do. It is Flask web tutorial. And if I click in here, I can see that I have an image called latest. And if I click into the latest image, then I can see kind of all of the stuff related to this image. Anyways, I'm not super concerned about looking at that, but we can see that we have Tech with Tim 0, Flask web tutorial latest. That is our image. So now that this is on Docker Hub, this is a public image, meaning anyone can view it. So keep that in mind. You only want to put open source code here. Don't put anything private unless you're going to make a private Docker Hub one, but that kind of involves a few different things. And now that we have this image, we want to go to our config.yaml file. So let's open up Sublime Text, which is what I was using here. Okay, Y is select folder. I don't want select folder. Okay, Sublime Text though. And now all I need to do is inside of my spec here for the deployment, I need to change the image that I want to run to be the name of the image that I just created. Now, again, for you guys, it will be different. I mean, theoretically, you can actually use this because it's public. So you can just put in what I have here or put in your own Docker image that you would have already created. Now, I will mention that if you wanted to make multiple containers, you would just copy this here and you put this here, and then you would just put whatever the other images that you want to run, give it a different name. Maybe the container port would be different if you're exposing a port, but that's kind of how you run multiple containers. Then all of those would be replicated 3 times. Anyways, I don't want to run multiple pods or multiple containers. I just want to run one and have it replicated 3 times. So that is what I am doing here. Okay, so I'm now going to save this file. Again, make sure it looks like this. You can download it from the link in the description. And now that we have this file, all that's left to do is actually put this on our Kubernetes cluster, and then we'll actually be able to view our Flask website from the IP address of our cluster or from our service. So I'm going to clear the screen here. And I'm inside, again, the directory where I have this config.yaml file. And what I can do now is type kubectl and then apply -f, which stands for file, and then the name of the file that I want to apply. Now, in this case, the file that I want to apply is called config.yaml. So I'm going to hit enter here and apply this, and it's going to create a deployment and create a service for me on my Kubernetes cluster. So now what I can do is type kubectl get pod, and you should see that we get 3 pods because we replicated the pod 3 times, right? And then if I go kubectl and get service, this is actually what we want to look at here. We can see that we have a Flask service. It is type load balancer, meaning it is external. Again, kind of a weird name here, but that's what it means. We have a cluster IP, and then we have an external IP. Now, the external IP is what I was talking about with the services that are external, and this allows us to actually access the service from this IP address outside of the cluster. So I'm going to copy this IP address, and then I want to look at the ports here. So when it shows me these 2 ports, what this means is I can access both port 5000 and port 32,194. Both of these are TCP ports, which are going to allow me to be routed essentially inside of whatever pod the load balancer sends me to, and then I will be able to hit the endpoint for my website. Okay, so let's see if the pods are running now. Okay, so they're all running, so that's good to go. Let's check our deployments. Okay, so let's say kubectl get deployment. It would be helpful if we spelt deployment properly. And we have our Flask deployment, 3 out of 3, up to date, available, awesome. Okay, so now let's go here and let's go to our browser. Let's paste in the IP address. Let's go to port 5000 and notice that I get my website. There you go. We just hosted a website. This is publicly available. Assuming I'm still running this cluster, which I probably won't be when you're watching the video, you could go to this URL as well, and you would be able to visit the website. Now, one thing to note here, because I realized I misexplained something. So for the ports for your external services, they're actually supposed to be within a specified range. I believe the range is something like 31,000 to 34,000. I don't know the exact range. But what this means here is not that it is running on both of these ports. That is incorrect. It means that when I go to port 5000, it's kind of an alias for the port 3002 or 32,194. And so that means I use port 5000, but really it's going to come in as this port when I put 5000 in my browser. At least I believe that's what's happening here. If someone knows precisely and they think I'm incorrect, then please do leave a comment. But from what I can tell, that's what's happening here. We're kind of aliasing this port, which is actually the port it's going to come in through as port 5000. But that still means that we can use port 5000 here to access the website. Okay. All right, so that is going to wrap up this video. Now, I know that I did not show you everything associated with Kubernetes. I did not go through all of the different features, but I thought this was a really good introduction video that even if you didn't follow along with, at least gave you a decent idea of how these things work and how easy it is to actually deploy, in this case, a distributed system where we have multiple pods running the same website. We're going to have a load balancer automatically set up for us. And if we had a website that was getting a ton of traffic, then we would just have more pods, right? And we could easily modify the deployment to replicate maybe 20 times, 30 times, 40 times, whatever, and Kubernetes would handle all of that for us. So with that said, I will wrap up the video here. I hope that you guys found this helpful. If you did, make sure to leave a like, subscribe to the channel. Thanks again to Linode for sponsoring this video, and I will see you in another one.